Not today. You will not necessarily need a graphing calculator today. Okay, so Unit 9 is all on quadratics. And if you guys took a look at your rubrics, Unit 9 is going to be broken down into 8 lessons, okay? The first lesson is going to be identifying quadratics. What does a quadratic look like? So we have 3 different sections here. We have a table, we have ordered pairs, and then we have an equation. Each of these could be a quadratic, and we have to look at it and determine if it is quadratic or not, okay? So the table, when we're looking at a table trying to determine if this table is a quadratic function, we're going to look at a couple of different things. The first thing that I'm going to look at is the x column. So I'm going to look at all these numbers under my x's. Are any of these, the biggest thing that you guys need to know about the x column is that they cannot be the same number. So the x column cannot have the same numbers.
So why there's negatives?
My stomach hurts.
So the x's, they cannot be the same, okay? Now, the next thing that we're going to look at are the y's. Now, when we're looking at the numbers in the y, we're going to find the difference of them not once, but twice. In order for it to be quadratic, the second difference must be constant. So the second difference must be constant. What does constant mean? And I'm not talking about a number without a variable. If something is constant, it's the what? The same, okay? So the second difference must be the same. Okay, so what does that even mean? What we're going to look at here is your y, and you're going to look at 4 to 1. To go from the number 4 to the number 1, what's the difference? How do you go from 4 to 1? What are you going to add or subtract to that 4 to get to 1?
3.
Or are you going to add or subtract it? Okay, so the difference is -3. So then we're going to find the difference of 1 and 0. So how do I go from 1 to 0? Subtract 1. How do I go from 0 to 1?
Minus 1. Plus 1.
And then how do I go from 1 to 4?
Plus 3.
Okay, so this is my first difference. So I found, for the first time, the difference between the numbers in the y. Now I'm going to go and find the second difference using the numbers I just found. Now, if they're all constant the first time, it's going to be a linear equation. It's going to be a linear. But because they're not all the same the first time, we're going to go and see if they're the same the second time through. So what we're going to look at then is -3 to 1. How do I go from -3 to 1?
Minus 2.
Not -2, +2. So -3 plus 2 will get me to -1. Okay, how about from -1 to +1?
1.
How do I go from -1 to +1?
Plus 1.
+2. And then from 1 to 3.
Plus 3. Plus 2.
Okay, so +2 plus +2 plus 2. +2 plus 2 plus 2. Those are what?
Positives.
Constant. They're the same. So because they're the same, it's our second difference. It is a quadratic function. So, example 1, it's yes. Quadratic function.
We don't got that room.
Can you fit it somewhere else on your sheet? So you're saying next year I need to make more space on the notes?
Mm-hmm.
I will be sure to do that. Thank you. Because the second difference is constant. What? It's an emergency? Yeah, we're right in the middle of a lesson. I prefer you wait if you can, unless it's an emergency. Okay. So, what is this table made up of? It's a function table. It's made up of numbers from x and y. What does x and y make up?
Coordinates.
Or an
Coordinate table.
or they make up an ordered pair, right? An ordered pair is made up of x and then y. what were we finding the difference of? Were we finding the difference of x, or were we finding the difference of y?
Y.
Y. So if I come to this next example, the relation, what do these numbers represent? What are those?
Y.
X, Y, or an unordered pair, right?
Yeah.
So if I'm looking at the ordered pair, I'm going to first check my x's. Now, an ordered pair is made up of x and y. I'm going to look at my x's. Are my x's the same number? Are my x's in the ordered pair the same numbers? Look, guys, look up here. Are my x's the same numbers?
No.
No. Okay. So then we can move forward. Now I'm going to compare my y's. I'm going to find the difference of my y's. Okay? Now, in order to find if it's quadratic, I'm going to have to find it 2 times, the difference 2 times. So let's look at my first difference. So what's the y value in this first ordered pair?
0.
What?
-5.
-5. What's the y value in my second ordered pair? Okay, so to go from -5 to -1, what am I going to add or subtract? So -5 plus or minus something to get to -1. So how do I go from -5 to -1? Plus 4. Okay. So then I'm going to look at this -1 and find the difference between the -1 and what number in my next ordered pair?
11.
11. So to get from -1 to 11,
Plus 9. Plus 10. Plus 11.
-1 plus, that's 12.
plus 12. So -1 plus 12 will get me to positive 11.
Okay.
Okay? And then what's the next 2 numbers I'm going to find the difference of? What's the next 2 numbers I'm going to find the difference of, you guys?
11 and 31.
Yeah.
Okay. And what are you going to do?
Plus like 20 something.
Plus 20.
Perfect. Okay. So that's the first difference. So now I need to go through and find the second difference, okay? So now I'm going from 4 to 12. How do I go from 4 to positive 12?
6.
Plus 6. Okay. How do I go from, that's not right. Let's try that again.
7.
Closer. 8. Okay. Now I find the difference between 12 to 20. How do I go from 12 to 20? What am I going to, so I'm going to add 8. Are these 2 numbers the same?
Yes.
Yes. So is this a quadratic function?
No.
Yes,
Yes. Why?
because it's the same.
Because the second difference is constant. So far, this we've seen before, the table. We've seen ordered pairs before. Have you guys seen an equation that looks like this before? 2x squared plus 5x minus 3. Have you seen an equation like that before? Y'all better say yes, because y'all just learned to factor them last semester, or last unit, okay? So, what we're going to look at now is the equation. In order for an equation to be quadratic, it has to have a power of 2, or a degree of 2. So the highest degree must be 2. So looking at this equation, 2x squared plus 5x minus 3, does it have the highest degree at 2? Yeah. So right there, that squared automatically makes it quadratic. So yes, it's quadratic because it's to the second degree. So if you guys remembered from Unit 7, when I talked about polynomials, we talked about the different degrees. If it's to the second degree, it's quadratic. If it's for the first degree, it's linear. If it's to the third degree, it's cubic. Okay? We're just focusing on quadratic to the second degree. Okay? All right. You all have this down? Okay, what I want us to look at is the second part of the table that's on your notes.
The one under this?
Yep, the one right under it. Let's take a look at right under it there. So we have the same thing. So what we're going to look at is the table. Is this table quadratic? Then we're going to look at our ordered pairs. Are these ordered pairs quadratic? And then lastly, we're going to look at our, on your own, we're going to look at our equation to see if that's quadratic. Now, in order to tell if an equation is in quadratic form, it also needs to be in standard form. What does standard form mean?
Simplest form. Like all the variables on one side and all that.
Yeah, you're getting there. So all the variables and numbers on one side, and they're put in order from least to greatest based on
Their exponents.
the exponents. Good. Okay, so looking at our table, the first question I'm going to ask myself, are all the numbers in my x column different?
Yeah.
Are any good? So if they're different, then I can go on to my y. What am I finding for my y column?
Oh, the quadratic function.
The difference between the two numbers. Now, how many times am I going to have to find the difference between the numbers in order to see if it's quadratic? How many times am I going to have to go through and find the difference in order to determine if it's quadratic? Look at the top of your... Twice. Quadratic means what?
To the second power.
To the second power to 2. So 2 is our magic number for quadratic, okay? Okay, so how do I go from 5 to negative 4? What am I going to have to add or subtract to 5 to get to negative 4?
Minus 4.
Minus 9.
Minus 9. So 5 minus 9 will get me to negative 4. Okay, what about from negative 4 to negative 7? So what do I add or subtract to negative 4 to get to negative 7?
Minus 3.
Minus 3. Good. Okay.
And then the next one is plus 3. And the next one after that is plus 9.
Okay. So I did that once. Are these numbers here all the same? Are these numbers all here the same? No. So they're not linear. Now, if those numbers were all the same there, our equation would be linear and would be done. But they're not the same. So we got to go on and find the second difference. So we go from negative 9 to negative 3. So negative 9 plus or minus what to get to negative 3?
Plus 6.
Plus 6. Negative 3 plus or minus what to get to positive 3?
Plus 6.
Plus 6.
And then plus 6 again.
So are all these numbers the same? Are they constant?
Yeah.
So is this a quadratic function?
Yes.
Why?
Because the second difference is different.
No, second difference
It's
is,
constant.
there we go.
Sorry, I was
That's-
saying something.
It's okay. It's all new stuff.
Are these all going to be constant?
Nope,
Are these all going to be quadratic?
nope.
Okay.
I don't know. I mean, nope, yes, maybe. We have to check them out. Okay, how do I determine if ordered pairs are quadratic? What am I going to look at first in my ordered pairs to determine if they're quadratic?
The Y.
Okay, first look at the x. Are the x's all different numbers? Yeah, they're not the same numbers. So then we look at our y's. So I'm going to look at my, what's my y here, Dylan? The two y's I'm going to look at first.
I have no clue where we are.
You're there.
Where?
So we're going to look at our y's. So negative 9 and,
-2.
okay. So how do we go from negative 9 to negative 2?
Plus 7.
Plus 7. There you go. Okay. So then I'm going to look at from negative 2 to negative 1.
Plus 1. And then negative 1 to 0 would be plus 1 again. And 0 to 7, plus 7.
Okay. So that's my first difference. Are these numbers
No.
constant?
No.
No. So because they're not constant, we know that it is not linear, and that means that we can go on to check to see if the second difference will be constant. So the second difference, we're going to look from 7 to 1. How do you go from positive 7 to positive 1? What are you going to add or subtract to that 7 to get to positive 1? So minus 6. Then 1 to 1.
0 plus 0
And then 1 to 7.
would be plus 6.
Are these three numbers the same?
No.
Are they constant? No. So is this a quadratic function?
No.
Why?
Because it's not constant.
No, because why?
The different
Second.
difference is not constant.
Good. Okay. Questions so far? Are we feeling pretty confident about what we've covered up to this point?
And a little half and half.
Half and half? Okay. All right.
Get there the farther we go.
Let's look at our equation now. Now, when you look at this equation, you might want to say that it's quadratic. I'm going to tell you that it's not. Can somebody explain to me why it's not quadratic even though there's an x squared?
Because the x squared is not connected to the 2. Like, it's not connected to the equation.
Are you supposed to have a squared in the denominator?
Yes.
No.
No. Okay, so this is not quadratic.
No.
Because the x squared is on the bottom or in the denominator. All right. Now, this last part that we're going to cover today is what does a quadratic graph look like? So if I would have you guys graph this out, what kind of line would that be on your graph? What does that curve mean? What is that called?
Non-quadratic.
No, what's that curved line called?
Parabola.
Parabola, yes. So if you look at the top of your paper, a parabola could be either upwards facing or downwards facing. So if you look towards the top of your notes, what are those two pictures at the top of your notes?
McDonald's and art.
Okay, so those are examples of parabolas. If I would take a line and draw that line right through the middle of those parabolas, would they be symmetrical?
Mm-hmm.
Yeah. So a parabola or a quadratic could be facing upwards or facing downwards. Okay, so let's talk about what makes up a quadratic function or a parabola. So these are the key terms that I want you guys to write on your paper. If you write big like me, well, actually, I was able to fit mine all on this
We have a
left
whole
side,
backside, too.
but there's a whole back side if you need to fit some key terms. So what we're going to talk about first is the vertex, okay? The vertex is written as an ordered pair, and it's either the highest or lowest point on the graph. So if we're looking at our graph right now, what would be the vertex?
-5.
Yeah, it'd be right down here. So this lowest part on my graph would be my vertex.
I remember learning this stuff.
Good, good. You're a
But
step,
I don't remember how to do it. Or
Dylan, you're a step ahead of me.
The only thing I know is the graphs.
Okay. So then the second thing, well, if the vertex is written as an ordered pair, let's go ahead and write that ordered pair. Now, this red dotted line does not represent my y-axis. A coordinate plane is made up of what two axes?
-2 and -5.
Yeah. So my ordered pair, or my coordinate plane is made up the x-axis and the y-axis, right? And the ordered pair is made up of x and y. I always start at my origin, which is right at the beginning of my coordinate plane. So if this is my origin and I find my x first, I go over how many? 1, 2. So if I go to the left, 2, it's going to be negative, as Lucas said. And then I count down 5 to the vertex. So the ordered pair for my vertex is what, you guys? -2, -5. Okay, the second key term that I want you guys to look at is maximum. Not every graph will have a maximum. It depends if that parabola goes up or down. So a maximum is the highest point on the graph. Does this particular graph, is the point high or low?
Neither.
Low. So this particular parabola has a minimum, which is the lowest point on the graph. So the vertex, not only is the vertex, but it also represents on the graph if it's going to be the maximum or the minimum. And in this case, as Dylan said, it's the lowest point, so it's going to be the minimum. So minimum is the lowest point on the graph. The next term that we're going to discuss is the x-intercept, okay? So we're looking at the x-intercept. What is the x-intercept? Lucas?
Like the coordinate?
What does that mean? I know I have the definition up here, but do you guys remember from
I do.
Unit 6 when we did graphing? What's the x-intercept mean, Lucas?
The line going through X.
Yeah, it's where the line crosses through the x-axis. How many times has my line crossed through the x-axis for this parabola?
Twice.
Twice. So that's going to be our x-intercepts. Now, what you guys need to know is that the x-intercept can also be called these three words. So if I tell you to find the root or the zeros or the solutions of the parabola, what I'm referring to is the x-intercept, okay?
What do those three words say? I can't read.
Root, R-O-O-T,
Nice. No,
zeros, and solutions, okay? Well-
There's sort of other doing that.
You just don't know how to do it? Okay.
I can't really see.
Move where you can, Caden. Move where you can. I do apologize. I know it's not written. I didn't type it out too big. Okay, so where does the parabola cross my x-axis? So where is my x-intercepts?
-2 and 2.
Okay, so we have the first one, which is right here. And my second one is here. So if I would ask you for the ordered pair of my x-intercept, what would it be? What would this ordered pair be?
2 and 2.
Nah, this is my x-axis, or my y-axis,
Oh.
and where my x-axis, where's that called? Where my x and y cross?
-2 and 0.
No, not yet. One of them. What is it called? Origin. And what's the ordered pair for my origin?
0, 0.
0,
And so where's this one located? In my origin? So it's going to be?
2, 0, and -2, 0.
So it's going to be 0, 0. And then this y-intercept is going to be what? So go over 1, 2, 3.
4.
So my x value is -4. And what's my y value? 0, because it's on the x-axis, right?
Yeah.
So again, these are called your x-intercept. It can also be called your roots. It can also be called your zeros. It can also be called the solution. Okay? So there's multiple names in which I can refer to that. The next term that I did not put on here that needs to be on here is going to be the y-intercept. What does y-intercept mean?
Intercepting the y
Yeah, where does the line intercept the y-axis?
at the origin. Other than that, it doesn't. Wait. -1. Yeah. -1.
Sorry, guys, a lot of writing there. Okay, so where does the line intercept the y-axis? So where does that line cross the y-axis? It's actually going to be the same as the what?
-1.
Nah.
It's the
Yeah.
same as the x-axis.
It's going to be the same as the x-axis, right?
I promise you.
'Cause it crosses our- Right there.
Miss Huntington,
Yeah?
you're wrong.
I am wrong?
Yeah.
Why do you feel that I'm wrong?
'Cause look.
Here's my y-axis right here.
Yeah. Look.
It's right here.
Check this out. Boom.
But that's not your x. Your x is up
that's your
here.
Y.
Oh, wait, hold on. My y.
That'd be -1.
Oh, I do agree.
Uh-huh.
Oh, Lucas just defeated me.
Wait, what? How would
Okay, so,
that be -1?
because it actually crosses the y down here first.
Oh, okay.
Yeah. So my x value is 0, my y is -1. Good job, Lucas.
Thank you.
So that's going to be my y-intercept.
I actually lost where the line was.
I did too. There's a lot going on there.
I thought the red line was the
Josh.
one.
Okay, the last term that you guys need to know what it means is the axis of symmetry. Okay? So the axis of symmetry intersects a parabola at the vertex. So basically it's right in the middle of that vertex where if we would fold it in half, it would mirror each other, okay?
So that red line
Yeah, so that red dotted line
is fifth album.
is going to be the axis of symmetry.
Okay.
Oh, we get over here at 50.
Okay. Any questions on this?
Are we gonna have homework?
You betcha. So the homework assignment that I'm going to give you mimics the notes that we just took.
Oh, that's
You're going to have to go through and tell if a table is quadratic. you're going to have to go through and tell if ordered pairs are quadratic and if the equation is quadratic. Then you're going to tell me why or why not they're quadratic, okay? So you can't just put yes or no. You have to explain why they are quadratic or why they are not. You're also going to have a graph where you're going to have to take and label it. And then you also are going to make your own graph with a parabola and label it, okay? Any questions? All right. Good job, guys.
Nice issue.